Hello, my amazing students. This is 7.1 homework help, and we're coming down to the finish line in this class. I'm so excited. I know you are. Final is this Thursday. So this is 7.1, and one of the problems on 7.1 was split up, and it was number 13, and on one part we were supposed to find the point estimate. On another one we were supposed to find the confidence interval. So I just put that all together and did it all together in one problem. So the problem was number 13, and it says, in a study of the accuracy of fast food drive-through orders, McDonald's had 33 orders that were not accurate among 362 orders observed. Based on data from QSR magazine, construct a 95% confidence interval for the proportion of orders that are not accurate. So they're asking us to look for a confidence interval for the true proportion given this data. So we're first going to talk about our point estimate, and our point estimate would be the 33 out of the 362, because their proportion is orders that are not accurate, and there were 33 not accurate out of the 362. So here I have provided a little sheet here for you, a little board. And I've got 33 out of 362 is my p hat, which is the proportion of my sample. When I crank that out, I get 0.09116. Your book's answer was 0.0912, so they rounded it a little bit. And our confidence level is 0.95. So then we go to our margin of error, which is our E. And this is the formula for our E. Hopefully you can see that. Okay, here's the formula for our E. And so then I plugged in, and looks like I forgot to plug something in here. Okay, so this over here is going to be 1 minus this, which is going to be 0.90 something. Okay, so basically I calculated all of this out for you, and I got this value right here is the square rooted value. Okay, and then I went to my Z chart, my normal table, and the alpha over 2, which is your two-tailed confidence interval, is going to be 1.96 for 95%. Those were found on the bottom, that little bitty chart that I've been showing you over and over. So 1.96. So then I take the 1.96 and I multiply it by this square root value that I got, and I get 0.0297. So that is the margin of error that goes with that problem. So here was the p hat. Okay, so the p hat was right here. And then the margin of error winds up being 0.0297, and those are correct. So now I'm doing my confidence interval, and the confidence interval is very easy once I've got my p hat and my E. So here is the confidence interval here. So I got p hat minus E, and then p hat plus E, and so then here I've got the p hat minus the E, and the p hat plus the E, and my true population proportion should be in there with 95% confidence. So then I crank this out, and I get the left boundary of my confidence interval is 0.0615, and the right boundary is 0.1209, and my true proportion is hopefully in there with a 95% confidence level. That was number 13. So the only thing that we had to do to finish up number 13 was to write out the statement for this confidence level, and I'm going to just read it for you because I didn't write it down. We have a 95% confidence that the interval from 0.0615 to 0.121, they rounded that a little bit, actually does contain the true value of the population proportion of McDonald's drive-through orders that are not accurate. So that is problem 13 in a nutshell. I just want to mention, if you have neglected to do your Chapter 7 homework and you would still like to get some credit for your Chapter 7 homework, I will still give you half credit if you carefully listen to this video, copy down the work that I'm giving you, and submit that as your assignment. It's going to be late, so it's only going to get half credit, but it's still something, and I give you the half credit because I figure you're taking the time to listen to the videos and hopefully learn how to do what you need to know how to do. Okay, so number 5 is extremely easy. We're told to find the critical value z of alpha over 2 for a 90% confidence level, and we have a little chart for that. So the little chart is right down here at the bottom of my z normal table, my z-scores. And you can see that for 90, it's 1.645. And these common critical values, when they're talking about the confidence level, they are talking about it being a two-tailed situation. So your critical values would be negative 1.645 and positive 1.645 to go with that confidence level. So the answer is 1.645. And there you have number 5. Okay, the last problem that we're going to do on 7.1 is number 31. Find the sample size needed to estimate the percentage of California residents who are left-handed. Use a margin of error of 3% points and use a confidence level of 99%. First of all, in A, we're going to assume that P hat and Q hat are unknown. Remember, when that's true, we use 0.5 for both of those. And then assume that based on prior studies, about 10% of Californians are left-handed, so we'd have a P hat of 0.10 and a Q hat of 0.90 for that one. And then how do the results for parts A and B change if the entire United States is used instead of California? Well, the answer to that one would be they won't change unless these percentiles actually change. So if there was a different percentage here for all of the U.S., that would change the answer. But if the percentiles were the same, nothing would change just because it was the whole U.S. instead of California. So let's work on A and B and get those values. The first thing I'm going to do is go down to 0.99 down there and get 2.575 as the critical value that goes with it. 2.575. So this is what I have. My formula for the number needed to perform the test is, this was a confidence interval, remember, in Chapter 7. So in order to get the correct confidence level at this level of accuracy or confidence is this is the formula right here. And so now I took the formula and I plugged in the value I just looked up on the z-score chart, which is 2.575. Now, a minute, I'll do the same thing with technology to get that value. But then once I've done this, I'm going to put here for the A where it says the P hat and the Q hat are unknown. I'm going to put here 0.5. And then over here, I'm going to be putting 0.5 because that's what we use when we don't know the P hat and the Q hat. Our error was 3%, so 0.03 squared, and that's my formula. So when I crank that out on the calculator, then I get 181,841.8. Okay, so rounding to the nearest whole number, I'm going to get 1842. All right, so that will be my answer for that one. So now I'm going to do the same problem. We're still working on A, but I'm going to do it with technology instead of my little table. So when we want to get a z-score, we're going to go to our inverse normal. And when we use our inverse normal, which is second, and go to your vars key, and then we're going to go down to number 3, which is inverse normal, then we're going to plug in the area that is in the tail. Okay, so if we're talking about a 99% confidence level split into two tails, that's 1% left, and we split it into two tails. So 0.01 divided by 2 is 0.005. So I'm going to put here, I don't know if you can see my screen. The light may be shining too much. Okay, 0.005, close it with a parenthesis, and I get negative 2.575829. Okay, so here is, that works better to show you my screen from behind. Okay, so that is the inverse normal, which is just a little different from the 2.575 that our book gave us. So it's really closer to 2.576 if we were going to round it. So let's use 2.576 as our value now and put it into the formula. So now I'm going to do the calculation again using, instead of 2.575 squared, I'm going to use 2.576 squared, and I'm going to do the whole calculation again to get the new number needed, minimum number needed to be able to perform the confidence level so that we get the technology answer. This was the by hand answer, so let's do this one. And our answer was only slightly different. We got 1,843 as the minimum number needed. And so that is going to be our answer for A. Either one of those, I would accept either one if I were grading a test, because they're both accurate. Now, usually our technology is considered to be more accurate, so getting your score from your technology is a little bit better, but hey, they're so close together. I'm not going to worry about one digit. I know that you did the work if you got 1,842 or 1,843. The book's answer is actually 1,844. So their technology is calculating it a little bit differently even than my technology does. So I'm not going to quibble about one either way on the answers. So just make sure you know how to do that number estimate. So now we're going to do the same thing, but now for part B, we're going to take the 0.5 out and the 0.5 out of that one, and we're going to put in 0.9 and 0.1. Because remember, they said that 0.10 or 10% was the p hat. So p hat, q hat, doesn't matter which order we do those in. And since we've already discovered that this score is a little bit better here than this one was, because this one was from technology, let's go ahead and use this one and find out the new value with the new digits put in there. So we'll erase this because that was the A answer. And now we'll do this one using we'll just put this A was or 1843 because that was our technology answer. And so now we're doing part B. Let's figure out what this is, because that will be the minimum number that we can use when we have a p hat of 0.1 and a q hat of 0.9. So I'm going to click this one in for you. And when I round the answer that I get 664, which was the book's answer. So the book got 1,844 for this one. I'm not sure how they did that, but the book got the 664 for the B portion. And that is the end of our homework for 7.1, and I will be back shortly with your homework for 7.2. This is Mrs. A, and may God bless your day.